Hello, this series is Maths and Graphs for Business and Economics. The topic today is percents for first year macro. It's presented by me, Linda Wannon, from La Trobe University, Australia. The three main ways percents are used in macro relate to proportions, growth and declines, and comparisons. Which of these methods you use depends on what sort of question you're asking and so what sort of answer you're wanting. The first sort is proportions. Let's look at a country's GDP and its component parts. The component parts are consumption, investment, government spending, and net exports. And let's say we have a country with billions of dollars, 400 consumption, 100 investment, 200 government spending, and 100 of net exports. Before we even think about percents, we must first add up these amounts. When we add them up, we get 400, 100, 200, 100, $800 billion. Then we find each value as a percent of the total. Looking at the first one, let's take each number, divide it by the total 800, and multiply it by 100. Your calculator may do this more speedily for you. So for consumption, 400 divided by 800 times 100 is 50%. Pause now to try it yourself. Pause frequently throughout this presentation to do the calculations yourself and confirm that you're getting it right. Continuing, the next one, investment. 100 billion divided by 800 billion times 100 to make it a percent is 12.5%. Continuing with government spending. 200 billion divided by 800 billion times 100, 25%. Net exports, 100 divided by 800 times 100, 12.5%. You now have all your proportions, but always check, do these percents add to 100? You must check. Let's have a look. 50, 12.5, 25, 12.5, yes, 100. If not, go back and redo the calculations. Let's try some real numbers. The GDP of Australia in a recent year. Consumption was 710 billion, investment 360, government spending 230, net exports minus 20. First, we add the numbers to find the total, even before we think about percents. Adding them up, we get 1280. Then we calculate the percents. 710 divided by 1280 times 100, 56% for consumption. Continue with the other components of GDP. What does percentage investment look like? Anything look strange? Put this on pause, do it yourself, let's have a think about it. Investment, 360 divided by 1280 times 100 is 29%. Government spending, 230 divided by 1280 times 100 is 17%. Net exports, minus 20 divided by 1280 times 100 is minus 2%. Yeah, there's something strange. Net exports can be negative component. When can this happen? Have a think. Correct. When a country exports less than it imports, you get a negative net export. Now you finally add up the percentage column. 56, 29, 17, minus 2. Yes, we do get 100. So even when a component part is negative, the total of the proportions still add up to 100. Interesting. Now, the next type of use of percents is macro, is growth and declines. These are a little like proportions. Here's an example. Suppose your country's GDP grew from 800 billion in one year to 900 billion in the next, so things are really booming along nicely. The growth as a percent is the comparison of the value of the change with the value of the original amount. So what do we compare? From 800 to 900. Let's compare. We compare the extra 100 with the original 800, convert this to a percentage when we multiply it by 100. So growth is new minus old, divided by old, times 100. 900 minus 800, divided by 800, times 100. 100 divided by 800, times 100. 0.125 times 100, 12.5%. Now try finding these growths as percents in your own time. GDP grew from 1200 to 1300 billion in 1 year. Investment was 360 billion 1 year, 450 billion the next. Exports went from 260 billion to 300 billion in a year. Consumption went crazy, from 710 to 850 billion in a year. Pause and do these. They're really good ones. When you're more confident with the type of calculation above, you may find this quicker. Divide the new by the old, subtract 1. Convert the remaining decimal to a percent. Example, 900 divided by 800 minus 1, 1.125 minus 1, which is 0.125. Convert that as percent, and it's 12.5%. That's a common way that I do percents. But if you're not confident, use the other previous method. What happens when we have a decline? Here's an example. Suppose your country's GDP fell from 500 billion in one year to 400 billion in the next. It does happen. The decline as a percent is still the comparison of the value of the change with the value of the original amount. So what do we compare? GDP fell. We compare the decline of 100 billion, not with the 400, but with the original 500, and convert this proportion to a percent when we multiply that by 100. So change is still new minus old divided by old times 100, which is minus 100 divided by 500 times 100, which is minus 0.2 times 100, which is minus 20%, a decline of 20%. Try finding these declines as percents in your own time. GDP fell from 1,300 billion to 1,200 billion in one year. Investment was 500 billion one year, 360 billion the next. Exports slid from 260 billion to 240 billion in a year. Consumer confidence slumped. Consumption went from 17 billion to 680 billion in a year. Pause now and have a go at those. When you're more confident with this type of calculation, you may find this actually quicker. Divide the new by the old, subtract 1, convert the remaining decimal to a percent. The example, 400 divided by 500 minus 1, 0.8 minus 1 is minus 0.20, which as a percent is a 20% decline. The minus means decline. Now the last major use of percents in the first year macro is comparison. These I find fascinating. They're often used to compare countries or to compare different economic factors within a country, or both, as we'll do. Let's learn by way of example. Let's look at the debt to GDP ratio for three major countries, the USA, Japan and Australia. At a certain point in time, the debt and GDP of each country was like this. 10.5 trillion debt in USA, 15.3 trillion GDP for USA. 9.5 trillion debt to Japan, 4.5 trillion GDP for Japan. 248 billion debt for Australia, 926 billion billion GDP for Australia. Interesting. Why are we interested in these things? Why are these of interest? Have a think. Before you actually come up with your ideas, note that the data we're looking at is from the CIA World Factbook website, accessed October 2012. It is national debt and GDP measured in purchasing power parity, estimated for 2011. So you're comparing apples with apples. Now, the reason why, let's have a think. Put it on pause, discuss. Come back from pause. One of the reasons why we're interested in debt to GDP ratios is, even though debt is not a component of GDP, we're not looking at proportions. The ability to pay off debt is based on your GDP. GDP is a kind of income. So a country's ability to pay off their debt is based on its GDP. Let's have a look at the calculations. Dividing 10.5 trillion by 15.3 trillion and multiplying by 100 gives us 69%. We don't have to worry about the trillion. The same unit of measurement is used in both debt and GDP, so all we have to do is divide 10.5 by 15.3 and multiply by 100 to make it a percent, and we get 69%. Doing the same thing for Japan. 9.5 debt, 4.5 GDP, both are in trillions. 9.5 divided by 4.5 times 100 gives you 211%. In Australia, 248 divided by 926 times 100 is 27%. What do you notice? Let's have a look at those numbers. Even though the USA debt is very high, Japan is higher as a percent. That's one of the major observations. What do you notice? These comparisons also don't add up to 100% like proportions. They don't look like growths in percents. They don't look like growths and declines as percents, but they're still very useful. Inter-country comparisons and comparisons of different macroeconomic variables are very useful for policymakers. Your final exercise is choose a country of interest to you, which might be, say, Greece, Italy, Spain, Turkey, Malaysia, China, India, any country you like. Calculate the debt to GDP as a percent for that country from data which you have obtained from a reputable source. I sourced my data from the CIA World Factbook, but you might be able to find the same data, but in your local currency, from another website. What I'd like you to do is discuss what can you say about your country's percentage, the percentage of debt to GDP. What does it compare? How does it compare with other countries? Is this level of debt sustainable? Why or why not? Put this on pause and have a discussion. When you come back, next slide. You are wished all the best for success and fun in your studies in economics. I hope you have as much fun with economics as I do. If you wish to keep in contact with us, do email us at allo.fbel@latrobe.edu.au. Goodbye.